Hey Valley, welcome back. Tonight we're going to be talking about experimental probability and theoretical probability. Start off with a fun trivia question, a delicious trivia question. We all know them, we all love them, M&Ms. What do the initials M and M stand for? We'll get back to that after our target. Officially tonight it's 9.7a. I can use the data from an event to determine the experimental probability. Sounds complicated? Easy target, you're going to like it. Let's do this thing. All right, here's the problem of the day. Johnny flipped a coin 450 times. His results are below. So he had 240 heads and 210 tails. Now we kind of know that theoretically he should have had 225 and 225. It should have been exactly half, right? But that's the difference between theoretical probability and experimental probability. What's supposed to happen doesn't always happen perfectly. All right, so here's what I did. We want to know what the experimental probability that the coin lands on heads is. So it landed on heads 240 times out of 450. I got to reduce that into a simple fraction in simplest form. So I divided by 10 first, and I got 24 45ths. And then I divided each of those two numbers, 24 and 45, by 3, and I got down to 8/15ths in simplest form. All right, but sometimes we like to express that probability in terms of a decimal. So if I take 8 divided by 15, let me grab my calculator real quick, clear this baby out. 8 divided by 15, just like the fraction tells us, I get 0.53 repeating as my decimal. If I take and move that decimal over 2 places, I get 53%. All right, so I can express it as a fraction, as a decimal, or a percent. But the actual experimental probability was about 53%, or 8/15ths. We would have expected it to be exactly 50-50, right? Okay, that doesn't always happen. Let's look at these two terms a little more carefully. So theoretical probability then, that's the mathematical odds of an event happening. Rolling this die here, the probability of me rolling a 6 is 1 in 6, right? Mathematically, that's what should happen. Okay, experimental probability, the actual results from an experiment, and they may not match the theoretical probability. Generally, here's what happens. The more often you perform an experiment, the more likely it will match the theoretical probability. I mean, you could flip a coin 50 times and have it all land on heads, right? 50 times in a row. There's a chance of it, pretty slim. But there's a chance that you could flip a coin and have it land on heads, 35 times and tails 15 times too, right? But more than likely, the more times you flip it, if you flip it 500 times, it'll probably get closer to your exact 50-50 type of probability. Okay? Let's take a look at an experiment here. I thought we'd just start with an experiment of our own tonight. So we're going to roll this die, and we'll just record what happens. We're trying to get the probability of a 6, and we think it should be 1 in 6, but let's do an experiment. So we roll it once, 5, put down, we'll just move this guy down to a 5, and roll it again. We got a 6, can move it down into 6, roll it again. Roll it down, move it down to a 3, roll it again. Move it to a 2, roll it again. We got a 5 again. I got to set this guy off to the side now because I've got 2 5s. And roll it one more time. I got a 1. So I've rolled it 6 times. 1, 2, 3, 4, 5, and 6. So I'm going to put down my 6. And I hit the number 6 one time. So my experimental probability here was 1 out of 6. My theoretical probability was 1 out of 6. They actually matched this time. Did it match for the 5? No, it didn't. Did it match for the 4? No, because I had 0 out of 6 for the 4, and my experimental probability for the 5 was 2 out of 6. It was double what should have happened. So you get an idea. of what experimental probability is. This is what actually happens when you do the experiment. And theoretical probability, this is what's supposed to happen mathematically, the odds or the chances. Okay? Tonight we're really going to focus hard on both those terms, even though our target talks about experimental probability. You kind of got to understand what's supposed to happen, right? And we've already talked about that a number of times. So I have 3 problems tonight. 2 for me to work, 1 for you to try. All right, so Amanda uses a standard deck of cards, 52 cards, and she selects a card at random. She records the suit of the card she picked, and then she replaced the card, and the results are shown in the table below. So she put the card back in, so there's always 52 cards. So here's what happened. Based upon the results, in this table above here, what was the experimental probability of selecting a heart? All right, so I had a total of 30 of these. She picked 30 times. If I add all these up, I got 5, 10, 15, 20. Here's 24, 25, 26, 27, 28, 29, 30. So she drew out 30 different cards. In terms of hearts, she got 5 here, 6, 7, 8, 9. She drew 9 hearts. So she had 9 hearts that she drew out of 30 times she drew, or 30 cards. That reduces down to a 3/10 probability, or expressed as a decimal, it's 0.3, and a percent as 30%. So I can have my 3 answers here as a fraction, decimal, or percent here. Okay? Theoretically, what should have happened? That's the second question. What's the theoretical probability of selecting heart? Well, there's 52 cards. There's 13 hearts in it because there's 4 suits. Reduce that down. Really, it's a 1 in 4 chance that she would draw a heart. Or express that as a decimal, it's 0.25. Or expressing that probability theoretically as a percent, it would be 25%. So her odds should have been 25%, but when she actually did it, she had 0.3 or 30% or 3/10, however you want to express that. It didn't quite match, did it? It usually doesn't. All right, here's an example for you to try. Here's my friend Bradley. Bradley spun this spinner 40 times and he recorded his results in the table. What was the experimental probability of landing on green? And what was the theoretical probability that that would happen? Go ahead and you answer these 2 questions on your own. Go ahead. Well, let's see how you did. Well, experimentally, he did it 40 times, and he had 6 greens right here, 6 of them. So he had 6 greens. If I reduce that down, that is 3/20 was the experimental probability, or 0.15 as a decimal, or 15%. All right, what should have happened? Well, when you look at the spinner, you can kind of tell. There's 4 equal areas, right? So theoretically, he should have hit a green 1 out of every 4 spins. So would have been 0.25 is the theoretical probability, or 25% chance of getting it. So he did not do as well experimentally as was, we predicted theoretically. Again, the results of the experiment don't always match the theoretical probability or the odds. All right? I've been using those terms a lot. One more time. Theoretical probability. This is the mathematical odds. 1 out of 4 times he should spin green. Experimental probability. That's what actually happens when you do the experiment or perform the experiment. All right. There's another example, and they like to do these kinds of problems here on tests, and I want to give you one. Johnny spins this spinner. Give it a spin. Come on, it won't spin. Well, there we go. Johnny spins this spinner 60 times and his results are below. So he had 17 black, 15 blue, 21 orange. Wow, just like mine. And 7 purple. What was the experimental probability of spinning orange? All right, well, he had a total of 60 spins. They did that for us, so I didn't have to count. And there were 21 orange. I got my 21. So 21 orange out of 60 spins. If I reduce that down, I divide by 3, I get 7/20. Or 0.35 is a decimal, or 35%. So I got these three ways of expressing that probability experimentally. I like using the percent, so it's a 35% of the time he spun orange. Think about that theoretically. It really should have only been 25%, right? It's 1 in 4 chance. All right, what's question B? They like doing this. Which color had an experimental probability that matched its theoretical probability? So now we got to think about which one of these numbers was at 25%. Well, what I do is I just take the theoretical probability. It's a 1 in 4 chance. Now, what do I have to multiply that denominator by to get to 60? Well, 15. So I multiplied 4 times 15 to get to 60. And whatever you do to the bottom, you got to do it at the top. So I multiplied the numerator by 15 too. And I found out that 1/4 is equal to 15/16. So if I look up on my data chart here, the spinner landed on blue exactly 15 times. So blue actually matched the theoretical probability. See how I did that one? All right, that happens sometimes. And sometimes you can just look at it and go, well, there's 60 spins. If I divide 60 by 4, I'll get 15. Yeah, blue matched it. I like looking at setting up the equal fractions. Okay? All right, here is your ticket to the show tonight. Johnny rolled the die 1,500 times, and his results are below. What is the experimental probability that the die will land on 4? You got your results. Go ahead and see if you can find that out. Make sure you express that in lowest terms. Thank you very much. All right, our trivia question of the day. What do the initials M and M stand for? Mars and Murray. When the company was originally founded, it was M&M Limited. The two M's represented the names of Forrest E. Mars Sr., the founder of the New York company, and Bruce Murray, son of Hershey's Chocolate president William F. R. Hope you enjoyed that trivia question. I'm hungry. All right, have a good evening. Bye.